When life on Jupiter was first seriously discussed in the 70s, there was only one place worth considering: the clouds.
You don't actually have a surface of Jupiter. You shine a big, strong radar pulse at Jupiter, and what you get back is 4 tiny blips. You see the moons of Jupiter just fine. In fact, we can study them by radar. Jupiter isn't there. It's like a stealth planet. If you had radar eyes, you'd wonder what these things were circling.
I've always been fascinated by the mysteries of space, and this one is truly mind-blowing. Scientists have detected strange objects near Jupiter, and what they found is beyond anything we expected. From Jupiter's moon, which has an active volcano running its daily activities, to the massive binary object larger than our planet swinging around Jupiter, this discovery has left experts scrambling for answers. So, let's dive right in. 10th, Great Red Spot. Over in Jupiter's southern hemisphere, the Great Red Spot is throwing a cosmic tantrum so grand that even Earth could fit snugly inside. Yep, this swirling storm is not just another weather pattern, it's a monstrous, counterclockwise spinning spectacle that puts all other storms to shame with its striking reddish hue. Now let's wind the clocks back to 1665. Italian astronomer Giovanni Cassini spots what he calls a permanent spot on Jupiter. Fast forward to the early 1700s, and poof, Cassini's spot vanishes, leaving us to wonder about its mysterious disappearance. Then, in 1831, another spot emerged, and this one's stuck around, making it a long-standing feature on Jupiter's cloud-wrapped face for nearly 2 centuries. Fast forward again to 1979, and NASA's Voyager 1 spacecraft decides to play paparazzi with Jupiter, snapping detailed glamour shots of the Great Red Spot. These photos weren't just for a cosmic photo album, they provided invaluable insights into the storm's intricate patterns and behaviors, offering scientists a closer look at what might be going on in that tempestuous atmosphere. But here's a plot twist. Our big blustery buddy is actually shrinking. That's right. From a whopping 40,000 kilometers wide in the late 1800s to a more modest 16,500 kilometers today. At this rate, we might be looking at a more circular storm by 2040. Why the downsize, you ask? Well, that's the million-dollar question that keeps astronomers scratching their heads and peering through their telescopes. And about that iconic red color, it's as much a mystery as a fashion statement. Some of the brainiest folks think it might be due to chemical reactions in Jupiter's atmosphere, getting a bit of a tan from the sun's ultraviolet rays. Imagine substances up there, catching some rays and turning into the red marvel we see. So, while we might not have all the answers about Jupiter's Great Red Spot, we do know it's one of the solar system's most fascinating features. Whether it's shrinking, changing colors, or just swirling away, it continues to captivate scientists and space enthusiasts alike. Here's to hoping it sticks around long enough for us to learn a few more of its secrets. 9. Volcanic activity on Io, 1979. In March 1979, NASA's Voyager 1 was just cruising past Jupiter, minding its own business, when it stumbled upon something extraordinary with its fancy cameras. On March 5th, as it zipped by Io, one of Jupiter's moons, the spacecraft sent back pictures that looked more like abstract art than moon maps. The surface was a wild mosaic of colors, with pits and peaks that wouldn't look out of place in a sci-fi flick. Now just imagine being Linda Morabito, the engineer at NASA's Jet Propulsion Laboratory. There she was on March 9th, 1979, poring over these images to pinpoint Voyager 1's location, probably sipping on her coffee when she spotted something truly bizarre. A gigantic 300-kilometer-tall cloud was just hanging out, stretching from the moon's surface into space. Linda's first guess? Maybe it's a photobomb by another moon. But nope, there was no such moon lurking behind Io. After a head-scratching analysis, the light bulb went off. This wasn't some cosmic smoke signal, but a volcanic plume erupting right before her eyes. This was no small potatoes moment. it was the first time anyone on Earth had seen an active volcano in another world. Talk about a career highlight. And as if one wasn't enough, further scrutiny of Voyager 1 snapshots revealed not one, not two, but 9 of these plumes dancing across Io's surface. Each of these findings confirmed that Io was more than just another pretty face in the solar system. It was volcanically alive and kicking. The discovery turned what we know on its head, proving that Earth wasn't the only hotspot for volcanic fireworks in the solar system. These revelations didn't just add a cool new factoid to space textbooks. They opened a new chapter on how we understand moons and planets millions of miles away. 8. Comet Shoemaker, Levy 9. Impact. Back in March 1993, a team of stargazers named Carolyn and Eugene Shoemaker, alongside their colleague David Levy, were hanging out at the Palomar Observatory in California. These folks weren't just any backyard astronomers. They were on a mission to hunt for near-Earth objects that might be zooming around our neighborhood. On the crisp evening of March 24th, while most of us were probably tuning into our favorite TV show, this trio was peering through the lens of a 46-centimeter Schmidt telescope. What they found wasn't the usual speckled starry scene. Instead, they captured an image of a comet, but not just any comet. This one looked more like a cosmic string of pearls stretched out across the sky. They quickly realized this wasn't an everyday find. The comet, which was later named Comet Shoemaker-Levy 9, SL9, turned out to be orbiting Jupiter, making it the first of its kind in astronomical records. Further poking around revealed that about 20 to 30 years prior, Jupiter's massive gravitational pull had snagged the comet, pulling it into an orbit that was too close for comfort. The result? Jupiter's gravity tore SL9 into a series of fragments that were doomed to crash into the giant planet. The anticipation built as astronomers calculated that these fragments would strike Jupiter between July 16th and 22nd, 1994. This wasn't just another day in the observatory. This was set to be a front-row seat to one of the cosmos' most dramatic shows. Observatories across the globe, along with the Hubble Space Telescope and the Galileo spacecraft, were all tuned in for the event. When the show began on July 16th, 1994, it kicked off with a bang. Literally, the first fragment slammed into Jupiter's southern hemisphere at a blazing speed of about 60 kilometers per second. The collision wasn't just a small blip. It generated a fireball that reached temperatures around 24,000 Kelvin and climbed over 3,000 kilometers above the cloud tops. For a little perspective, that's like stacking about 375 Mount Everests on top of each other. Over the course of 6 days, Jupiter took a beating from a total of 21 fragments, each leaving its own dark mark on the planet's atmosphere. These weren't just blemishes, they provided a goldmine of data about Jupiter's atmospheric makeup and dynamics. The most jaw-dropping impact came from fragment G on July 18th. This one left a scar over 12,000 kilometers wide. Yup, that's roughly the size of Earth, and released energy comparable to 6 million megatons of TNT. The whole Shoemaker-Levy 9 episode was a blockbuster moment in planetary science. 7. Magnetic tornadoes near Jupiter. In the late 1990s, when most of us were probably grappling with Y2K bugs, astronomers peering through the Hubble Space Telescope were scratching their heads over some rather odd features near Jupiter's poles. These weren't just any random blips. They were mysterious dark ovals, each the size of Earth, playing a celestial game of peekaboo at the poles. Now, these ovals weren't exactly the type to stick around for a selfie. They appeared and disappeared unpredictably and were only visible in ultraviolet UV light, which meant ground-based telescopes were pretty much useless in spying on them. Enter NASA's Cassini spacecraft in 2000, doing a flyby on its way to Saturn. Cassini played the role of cosmic detective and confirmed these elusive dark spots at Jupiter's North Pole. Despite the spacecraft's best efforts, the origin and nature of these features remained a big question mark. Fast forward to 2024, and a team of sharp-eyed astronomers from the University of California, Berkeley, and the University of Leicester decided to take a deep dive into decades of Hubble data. Thanks to the Outer Planets Atmosphere Legacy (OPAL) program, which has been snapping pics of the outer planets for over 28 years, they had plenty to work with. After some serious data crunching, the team had an aha moment. These dark ovals weren't just hanging around. They formed in about a month and faded out after several weeks. Throughout their observations, they spotted 8 of these ovals at Jupiter's south pole and 2 at the north pole. So, what's the magic behind these vanishing acts? It turns out these dark ovals are the result of magnetic vortices. Think of them as magnetic whirlwinds caused by the interaction between Jupiter's strong magnetic field and a ring of electrically charged particles. These particles get their start from the volcanic eruptions on Jupiter's moon, Io, and boy, do they put on a show. As these magnetic whirlwinds whirl away, they pull dense, hazy gases upward into Jupiter's atmosphere. 6. Jupiter's rings. Back in 1979, NASA's Voyager 1 spacecraft was cruising through the cosmos, bound for the outer planets, when it stumbled upon something totally unexpected around Jupiter. Until then, everyone was pretty sure Saturn was the only one in our solar system cool enough to rock a set of rings. But lo and behold, on March 4, 1979, Voyager 1 snapped a photo that would change the way we see Jupiter forever. Launched on September 5, 1977, Voyager 1's main gig was to get up close and personal with the outer planets. By March 1979, it had reached Jupiter, ready to snap pics and gather all the juicy details about the giant planet and its moons. As it edged closer, one of those photos brought the house down, a faint, thin ring circling Jupiter. Yep, Jupiter's got rings, folks, and it was showing them off for the first time ever. Now, let's break down this ring system, because it's not just any old celestial accessory. We've got the main ring, which is like the show-off of the group, thin, bright, and made up of tiny rock and dust particles. Then there's the halo ring, playing it cool just inside the main one, thick and faint, made of even tinier particles. And don't forget the gossamer rings. Yes, there are 2 of them, sprawling out wide beyond the main ring. These are crafted from dust kicked up from Jupiter's moons, Amalthea and Thebe, giving a whole new meaning to moonshine. These rings might not have the bling of Saturn's, since they're fainter and mostly dust, but they're fascinating in their own right. The whole setup suggests these particles come from Jupiter's small inner moons. Picture this: meteoroids zoom by, smack these moons, and voila, dust particles get ejected and end up as rings. Finding Jupiter's rings was like hitting the cosmic jackpot. It not only turned our understanding of ring systems on its head, but also showed us that these features might be more common than we thought. This groundbreaking discovery has since been a goldmine for scientists, offering a front-row seat to the intricate dance between planets and their moons. So when next you're gazing up at the night sky, remember that even the stars and planets can surprise you with a secret or 2 hidden up their cosmic sleeves. Who knows what else is out there just waiting to be discovered? 5th, Galilean moons. In January 1610, Galileo, an Italian astronomer, was about to shake things up. While tinkering with his homemade telescope, Galileo spots 4 bright sparks near Jupiter. At first glance, they seem like stars, just part of the cosmic backdrop. But hold up, these weren't any ordinary stars. Over several nights, Galileo notices they're dancing around Jupiter in a way that stars just don't. Now this is where it gets juicy. Galileo realizes these bright objects are moons orbiting Jupiter, not stars at all. And just like that, he blows the lid off the old-school belief that everything celestial spins around the Earth. We now call these moons the Galilean moons: Io, Europa, Ganymede, and Callisto, the first ones spotted around another planet. This discovery of Galileo's didn't just add a few points to his astronomy score, it launched a full-on revolution against the geocentric model, a view that had the Earth playing center stage. Instead, Galileo's observations fueled the heliocentric theory, which posits that planets, including Earth, actually orbit the Sun. This was radical stuff, because it suggested that Earth wasn't the universe's center of attention. Let's talk size for a second. These Galilean moons are no small fries. They're some of the largest objects in our solar system, outside of the Sun and the 8 planets. In fact, Ganymede isn't just another moon. It's the solar system's heavyweight champion, even bigger than the planet Mercury. That's right, a moon outsizing a planet. Galileo's stargazing didn't just expand our cosmic knowledge, it even had down-to-earth benefits. Mariners later used the predictable paths of these moons to nail down longitude, a game-changer for navigation. So, next time you find yourself lost at sea, maybe say a little thank you to Galileo and his telescope. In a nutshell, Galileo's peep through his telescope one cold January night didn't just spot some moons, it redefined our place in the cosmos. 4 new moons discovered. Back in 2017, a team of astronomers, led by the ever-curious Scott S. Shepard from the Carnegie Institution for Science, was busy scanning the skies with their high-powered telescopes in Hawaii and Chile, hoping to spot distant objects in our solar system. They noticed a few extra blips on their radar during their celestial stakeout near Jupiter. And not just any blips, these were 12 never-before-seen moons dancing around the giant planet. These moons weren't exactly showstoppers in size, each one measuring less than 2 miles across. Still, their discovery was nothing short of stellar. Now get this, 9 of these new moons were happily doing their orbit in one direction, while 2 decided to be rebels and go the opposite way. But the real star of the show was the 12th moon, named Valetudo. This little moon was an oddball, orbiting in the same direction as Jupiter's spin, but weaving through traffic like a scooter in rush hour, crossing paths with those contrary moons. When they announced their findings on July 16, 2018, Scott Shepard was like, "We weren't even looking here on purpose." Their main gig was searching the outer solar system, yet here they were, discovering moons around Jupiter by happy accident. It just goes to show how much mystery is still out there, waiting to be unraveled. Third, rare Martian meteorite travels millions of miles. In 2012, scientists had a bit of a cosmic jackpot moment when they got their hands on a rare meteorite that had hitchhiked all the way from Mars. This wasn't just any space rock, but Northwest Africa, NWA 7034, affectionately dubbed Black Beauty. This little piece of the galaxy landed in the Sahara Desert back in 2011, and it's been turning heads ever since. So, why all the fuss about an 11-ounce rock? First off, this meteorite is old, like 2.1 billion years old, placing it squarely in the Martian Amazonian period. That's significantly more ancient than the majority of Martian meteorites we've laid hands on before. But age isn't all it has going for it. Black Beauty is also a bit of a water hoarder. It packs about 10 times more water than its fellow Martian rocks. Why does this matter, you ask? Well, this suggests that back in the day, Mars wasn't the red, dusty, barren wasteland we see today. Instead, Black Beauty hints that Mars had water-rich environments billions of years ago. Picture this, the very crust of Mars, soaking up water like a sponge. That's the story this rock tells us. Now let's get into the nitty-gritty of what Black Beauty is made of. We're talking about cemented fragments of basalt. Yep, volcanic rock. This means our little space traveler was born out of volcanic activity on Mars. What's cooler is that its composition is a close match to what Mars missions have analyzed from the Martian crust. It's almost like having a piece of Mars right here on Earth to study. The saga of how NWA 7034 found its way to our planet is as dramatic as any space odyssey. It started with a bang, a violent impact event on Mars that launched our heroic rock into the cosmos. After an epic journey through the solar system, it crash-landed on Earth, bringing with it secrets of the Martian past for us to unravel. 2. The unusual centaur, named 2060 Chiron. Back in 1977, while most folks were grooving to disco and sporting bell-bottoms, astronomer Charles Kowal was busy making history with a real head-scratcher discovery. It was a typical night at California's Palomar Observatory, and Kowal peeking through the mighty 48-inch Schmidt telescope on the nights of October 18th and 19th, spotted a mysterious, slow-moving object lurking between the orbits of Saturn and Uranus. Enter stage left, 2060 Chiron, a cosmic enigma initially pegged as just another asteroid. But here's where it gets juicy. Chiron wasn't content to fit neatly into the asteroid box. Nope, it started showing off characteristics that had scientists scratching their heads, wondering if it was more of a comet than an asteroid. Thus, Chiron got a promotion to centaur status, not because it's half horse, half human, but because it embodies traits of both asteroids and comets. Talk about having an identity crisis. Now let's talk about Chiron's path through space. It's like it's on a cosmic roller coaster, taking about 50.45 years to make a full lap around the Sun. Its orbit is a bit of a wild ride too, weaving through Saturn's territory and cozying up close to Uranus. But hold on to your hats, because this orbit isn't stable. Thanks to the gravitational tugging from the neighborhood planetary giants, Chiron's trajectory is all over the place. Flash forward to 1989, and astronomers Karen Meech and Michael Belton noticed something peculiar, a glowing halo, known as a coma, typically a comet's signature look surrounding Chiron. This was a curveball because remember, comas aren't usually an asteroid thing. This finding suggested that Chiron might be packing water ice and other gassy goodies beneath its surface, blending the best of both asteroid and comet worlds. The plot thickens with recent peeks through the James Webb Space Telescope, revealing that Chiron is quite the mixed bag, with surface ices like carbon dioxide and carbon monoxide, and a gaseous coma boasting a bit of methane. These insights are more than just cool space facts. They give astronomers clues about Chiron's origins and its role in the cosmic ballet of our solar system. First, jumbos. In 2023, astronomers using NASA's James Webb Space Telescope stumbled upon a cosmic curiosity in the Orion Nebula, some 1,344 light-years away from our cozy little planet. Now, the Orion Nebula isn't just any old spot in space, it's a bustling nursery for new stars. But the latest residents of this stellar creche are not stars. Nope, they're something entirely unexpected. Pairs of Jupiter-sized objects wandering freely through space without a star to call home. They've been adorably dubbed Jupiter Mass Binary Objects, or jumbos for short. Here's the scoop. Scientists found not one, not two, but about 40 pairs of these jumbos. Each duo is made up of objects roughly the size of our solar system's own gas giant, Jupiter, bound only to each other, orbiting in a celestial dance, Sun's stellar accompaniment. It's like finding out Jupiter has a secret twin it never knew about, and they're both living the free spirit life out in space. This revelation was quite the head-scratcher for astronomers. Traditionally, planets form from the dusty, gassy disks that swirl around young stars, kind of like cosmic cotton candy machines. But these jumbos, they're not playing by those rules. They either formed in low-density areas, unable to muster up enough material for a star, or they were booted from their stellar homes, sent packing by gravitational bouncers. Thanks to the UST's eagle-eyed tech, astronomers could observe these jumbios with clarity and detail that was previously just a pipe dream. With its top-notch sensitivity and resolution, this space telescope not only detected these elusive pairs, but also opened a whole new chapter in our understanding of how celestial bodies can form and evolve. So, what's next for these wandering giants of the cosmos? Further studies are on the agenda. Scientists are now eager to unravel the mysteries of these jumbos' origins and characteristics. Are there more of them out there, frolicking freely in other cosmic neighborhoods? Only time and a lot more cosmic sleuthing will tell. One thing's for sure, space never ceases to amaze. Just when you think you've got the universe figured out, it throws you a curveball, or in this case, a couple of Jupiter-sized curveballs. And that's a wrap, everyone. What do you think about this mysterious discovery near Jupiter? Share your thoughts in the comments below. If you found this fascinating, don't forget to give this video a thumbs up, subscribe for more mind-blowing space content, and hit the bell icon so you never miss an update.